Welcome again to our course on Biodesign, Strategies for Innovation and Design on Bioengineering. Today we're going to talk about a very important topic, prototyping. So prototyping is going to become critical in your innovation process, as it's going to be the medium for you to convey your ideas to your team and to everybody else. Okay, prototyping, as you're going to see, can range from drawings to physical things to show that can actually work. But as we're going to see today, prototyping has a range of different ways in which you can act and in which you can at the end convey your ideas. So for today's objectives, what I want you to know is to understand how to approach prototyping and the different types of questions it can help address. Also, I want you to learn how to think about and translate concepts into functional blocks for more efficient and direct prototyping. I want you to become also familiar with some prototyping tools for which I'm going to talk about, and also techniques and how to apply them in different engineering disciplines to get the most of it. Also, I want you to understand how to use prototyping to create design requirements and to generate high-level specifications related to technical feasibility, which is going to be something really critical that you want to answer at these stages, since it's a non-costly stage for you to develop such requirements. Also, I want you to know how to use the Biodesign testing continuum, as we're going to call it, to transform the concepts into increasing advancing prototypes. As you're going to see, you're going to change from a very basic ones to very developed ones, but at the end I want you to understand how to do that. Okay, so if we think about prototyping, it almost can be thought as an evolutionary process. It goes from an early very stage type of prototype to a final solution that is probably going to be costly, expensive, complex, time consuming, and it's going to use different final materials. Nonetheless, what it's going to be important for you to know at this stage of your innovation process, in which you are still trying to figure out the ways, the different needs that you want to solve and the different concepts that you want to try to solve them, what it's going to be important is that you really understand what an early stage prototype really means. And a very easy way to understand it, that it almost has four exclusively important characteristics. An early stage prototype has to be simple, inexpensive, quick to do, and it should use surrogate materials. Thinking about this, it's very important for you to acknowledge these four things in your mind when you do your early stage prototypings, because what you're going to see is that you're going to be compelled to create more complex final types of solutions, and probably this is not going to be the stage for you to do that. That's going to come later, but at the very beginning, please try to do early stage prototypes in a simple, inexpensive, quick, and using surrogate materials. Okay, so what is the Biodesign testing continuum? The Biodesign testing continuum, as you have seen in this course, includes a non-clinical, kind of like a need assessment part. Also, it has a concept generation stage, a prototyping stage, an R&D stage, a preclinical stage, which is all the testing done in vitro or in the bench and in animals, and of course the clinical part. And at the end of that Biodesign testing continuum, there is going to be the implementation of the business models and the creation of value. In this sense, for today's class, we're going to focus on the prototyping stage, which includes, as you are looking at this slide, in 5 different stages. So when thinking about also the Biodesign testing continuum, the only thing that you have to get at the very end of this is that it's going to evolve. What you're going to have is, first, you're going to try to convey your ideas through very early stage prototypings that can include a drawing in a napkin or some stuff that you can buy in a paper store put together to convey your ideas. Your devices, as you move on with different concepts, as you are validating them, they are going to change into more sophisticated functional prototypes. But at the very end, what you want to get from a prototype is first that the idea is completely conveyed through them, and at the end that you are spending the least amount of time by proving different parts, functional parts of your prototype, and at the end what you want to have is a prototype that is good enough for you to test them on a preclinical and non-clinical setting. After you have resolved the most significant questions from your concepts through prototyping, then that means that you are ready to start in an R&D phase. As you're going to see also in this Biodesign Continuum, is that the prototyping and the R&D stage sometimes overlap. Since your prototype becomes a beta prototype or an alpha prototype in somewhere in this process, which at the very end could be used for preclinical and even clinical testing if done in a very correct manner. Nonetheless, a good rule of thumb is that a prototype is gonna just finish until your preclinical phase, and you're gonna require a more sophisticated R&D process in order to create devices that are good enough and have the quality that it's required to undergo animal and clinical testing. Okay, so what are the different ways in which you can prototype? As we have mentioned, you can do drawings in a very early stage, so that's encouraged, as we have seen in our brainstorming sessions. So something really quickly to show how this works. But when doing prototypes strictly, what you want to do is to do something more formal. You want to do explosions and drawings and things that can show exactly how the shape is and how the device works and how the mechanisms act in order to create the clinically relevant effect. In this case, some things that you have to do in order to convey these ideas in most medical devices to create explosions and different views of how your product looks like and how it works and how it's used. In this case, you should always include an isometric drawing, a cross-sectional drawing, and any other computer-aided design which you feel is enough for you to convey your idea, and also to show doctors and stakeholders on the different things and features that your device has and that makes it work. In the specific case of our example of this presentation, you have a syringe that has a valve for pressure release, probably used in some sort of inflation device for tracheal intubation. And in this case, what you want to convey is that it's a simple normal syringe which has an embolus, a plunge, and every other single aspect of a syringe, a lure, etc. But that it also has added a system for pressure release, which includes a spring, a valve to occlude the entry of air, and of course an exit. Probably for that you are going to need an explosion, a top drawing, a cross-sectional drawing, and also some orthographic projections in which you are going to exemplify the different measurements and things that you have to have in your product in order for it to work. It is important that in this stage you present the data, and just the data that it's really required for the device to work. So if there is a measurement that it's not really essential for the device to work, you should not pursue in an early stage prototyping phase to try to solve that, because what it's important is to validate that the measurements that are critical are actually important and that they will work in the anatomy and physiology that you're trying to solve. Of course, CAD drawing and views of the explosion of how the device looks is something really important when thinking about mechanically oriented solutions. Nonetheless, you're going to see that there are solutions that are that come into the realm of electronics, and for this there are also prototyping techniques. In this case, for example, for prototypes in terms of circuits and control systems, you're going to have block diagrams. There are different ways of doing block diagrams in which there are situations and cases in which you have to interact in order for a flow in your block diagram to go. But in the specific case of our ECG block diagram that we are showing here, what you're going to see is that you have several blocks that create different effects. In this case, there is an input for the ECG, the electrocardiogram. there is an input, there are sensors, there are filters, there are amplifiers, there is an analog to digital converter, there is a microprocessor, so a computer, a brain that processes this, and an output, which can be a screen. And the process, the process of how the device works has to go in the sequence that you're describing in the block diagram. This is going to be really important for you to convey how your device works if it's non-mechanical exclusively. Another way in which you can further prototype these types of blocks is to think about what is the specific electronics in a high level that are required for each block to work in the way you're describing it. In our example of an electroencephalogram, or in the case of any traditional basic measurement system for biological signals, you're going to have, for example, an operational amplifier, which has different resistors and operational amplifiers in a certain architecture that is going to make it work, and which can be proved mathematically or by any other means, but it's also important to describe them as it conveys that you have an idea of how to actually solve the problem and create the effects that you are mentioning on your block diagrams. Further prototyping, once you have all those early stage prototyping already done, so schematics and calculations of how the circuitry is going to work, it's going to go into a more higher level in terms of how you're going to collect the signal, how the circuit is probably going to look, and then what are the other blocks that are going to be included. So is there going to be a data acquisition system in order to store the data or process that? What type of monitor I'm going to use? What type of interface is the user going to have in order to know the important things of the information that you're getting from the electroencephalogram? And this is something important to early on describe in your prototypes, even though it could only be on paper. And with this in consideration, just please take into account that prototyping can be done in many different ways. It goes always from the simple, inexpensive to the most costly and expensive types of prototyping. Very early on in your innovation process, please try to do as quickly tests and proofs and prototypes as possible. And later on, when you are validating your prototypes, you can move on to more specific materials or more sophisticated ways of creating your prototypes. At the end, the important part about prototyping is that nobody that is looking at your project and your concept has any doubt about how the device looks and works, because if you are capable of conveying that idea, then it means that the probability of success of your products is going to be higher than if you come up with a concept in which you don't have any idea of how to solve it through engineering. And with this, we have concluded our module on prototyping. For any other information, please consult our chapter on prototyping on our Biodesign book from Senius and Stanford Biodesign. My name is Luis Soengsen, and thank you for watching.